Imagine holding a tiny spoonful of matter in your hand. It looks completely ordinary, yet it hides a mind-blowing secret that could change the way you see the universe forever. Yet it weighs over 1 billion tons, more than an entire mountain, more than millions of elephants combined. It would crush everything beneath it instantly. This isn't science fiction. This incredible substance actually exists inside one of the most mysterious objects in the universe, a neutron star. These stars are so extreme that they bend space and time, spin hundreds of times every second, and possess magnetic fields powerful enough to destroy atoms from thousands of kilometers away. But how can such a tiny object become heavier than our imagination? Today, we're exploring one of the strangest and most fascinating wonders of the cosmos. What is a neutron star? A neutron star is the collapsed core of a giant star that was once at least 8 times more massive than our Sun. Throughout its life, the star produces energy by fusing lighter elements into heavier ones. Eventually, it creates iron in its core, and iron cannot produce energy through fusion. Without the outward pressure from nuclear fusion, gravity suddenly wins. Within seconds, the entire core collapses inward at incredible speed. The outer layers explode violently in a spectacular supernova, while the core becomes compressed into an unbelievably dense ball made almost entirely of neutrons. Although the original star may have been millions of kilometers across, the remaining neutron star is only about 20 kilometers in diameter, roughly the size of a city. How dense is it? The density of a neutron star is almost impossible for the human mind to understand. Imagine compressing the entire mass of our Sun into a sphere no larger than a small city. That's exactly what nature does. A single teaspoon of neutron star material would weigh approximately 1 billion tons, although some estimates place it even higher depending on the star's composition. To understand this, imagine combining the weight of Mount Everest, millions of blue whales, and every car on Earth into one tiny spoon. If such material could somehow be brought to Earth, which is impossible, it would punch straight through the planet due to its immense gravity. Nothing on Earth comes close to this level of density. Even diamonds, lead, or uranium are practically empty space compared to neutron star matter. What happens inside? Inside a neutron star, atoms no longer exist the way we know them. During the collapse, electrons are forced into protons, creating neutrons through an incredible process called electron capture. The result is a gigantic sphere packed almost entirely with neutrons touching one another. Scientists believe the outer crust is made of extremely compressed atomic nuclei, while deeper inside lies a sea of superfluid neutrons, a strange form of matter that flows without friction. At the very center, conditions become even more mysterious. Some physicists think the pressure may be so enormous that neutrons themselves break apart into their fundamental particles called quarks, creating an exotic state known as quark matter. However, no one knows for certain because these conditions cannot yet be recreated in laboratories on Earth. The fastest spinning stars. Neutron stars are also among the fastest spinning objects in the universe. As the original star collapses, its rotation speeds up dramatically, just like a figure skater spinning faster when pulling in their arms. Some neutron stars rotate once every few seconds, while others, known as millisecond pulsars, spin more than 700 times every second. Imagine an object heavier than our Sun spinning faster than a kitchen blender. As they rotate, beams of radio waves, X-rays, or gamma rays shoot from their magnetic poles. If these beams sweep across Earth, astronomers detect regular pulses of radiation, causing these objects to appear as blinking cosmic lighthouses. That's why many neutron stars are called pulsars. If the density of neutron stars isn't impressive enough, their magnetic fields are even more astonishing. Some neutron stars, known as magnetars, possess the strongest magnetic fields ever discovered in the universe. Their magnetic force can be 1 trillion times stronger than Earth's magnetic field. If a magnetar came within about 1,000 kilometers of Earth, its magnetic field could erase every credit card, destroy electronic devices, and even rearrange the atoms in living organisms. Fortunately, the nearest known magnetars are safely thousands of light years away. Occasionally, magnetars release enormous bursts of high-energy radiation that can briefly outshine almost everything else in our galaxy. Paragraph 7. Comparing neutron stars. Let's compare a neutron star with objects we know. The Earth has a diameter of about 12,742 kilometers, while a neutron star measures only around 20 kilometers across. Yet, despite being about 600 times smaller in diameter, a neutron star can contain up to twice the mass of our Sun, which itself is over 330,000 times heavier than Earth. If Earth were compressed to the density of a neutron star, it would shrink into a sphere only about 200 meters wide, roughly the length of 2 football fields. Imagine fitting our entire planet into the size of a sports stadium. This comparison reveals just how unbelievably dense these cosmic objects truly are. Paragraph 8. The future and final mystery. Neutron stars continue to challenge everything scientists know about physics. They allow researchers to study gravity, nuclear forces, and matter under conditions impossible to create on Earth. Sometimes, 2 neutron stars collide, producing one of the most energetic explosions ever observed, and creating precious elements such as gold and platinum that eventually become part of planets and even the jewelry we wear today. These collisions also generate gravitational waves, tiny ripples in space-time that travel across the universe. Despite decades of research, many mysteries remain unsolved. What truly exists inside their cores? Can quark matter really form? And what happens at the absolute limits of density? One thing is certain, neutron stars remind us that the universe is far stranger, more powerful, and more extraordinary than we could ever imagine. Outro. So, the next time someone tells you that a spoonful can't weigh 1 billion tons, you'll know that somewhere in the vast darkness of space, nature has already made it possible. If you enjoyed discovering one of the universe's most extreme objects, don't forget to like the video, subscribe to the channel, and join us for more incredible mysteries of science and space. Until next time, keep looking up, because the universe never runs out of surprises.